Hello, everyone, and welcome back. In this video, I want to talk about the function in MIPS. In the high-level language, you can easily call a function and pass some argument to the function. But how we can do this operation in the MIPS assembly language? Let's see first what happened when we call a function in the high-level language. First of all, when you call a function, we have a color program and a color program. So the control should pass from the color program to the color. And also some argument should be passed to the corresponding local variables. Then some local variable also should be allocated in the memory. And after we finish the body of the function, this local variable should be destroyed and also the return value should be passed or come back to the color program. All of this operation should be performed in order to successfully call a function in the MIPS assembly language. We have a new instruction for calling a function in order to pass some parameters to the function. We can use some specific registers. Register $1 a 0 registered unassigned a 1 a 2 a 3 are used to passing the arguments and register $V0 and some V1 are used to return some value to the color program. Also, a function can use the stack memory to save the return address and also to pass some parameters. When we call a function or invoking a function, the control flow of a program change two times. First time when we're calling the function and second time when we're returning from the function. Let's raise this program together. Here we have a function fact and we call it for the first time in this line. So the CPU should store the return address of this function before we jump to the startup of this function. So we return this line address somewhere and then the control flow of a program come to this line. After we compute the factorial and reach to the return instruction, we should come back to the color program. We restore the return address, and by this way, we come back exactly to the same part that we should. Again here we call the same function, so we execute the same code in the memory. But this time the return address should be this part. We should come back to this line, but in the first time the return address should be here. So how we return to different address when we run this return f the CPU store, the return address before we call function. So how we can call a function in MIPS language? We have a special instruction for this purpose, jump and link instruction. So as you can see, jump and link receive one operand. The name of the function that you want to execute or invoking. Let's check what happens when we call a function. As we said, the return of this should be saved somewhere. So you know that we have a specific registered program contact which points to the next instruction that should be executed by the processor. So if we store the value of the program counter into some place, we can use it as the return address in MIPS assembly language. The return address is always stored in a specific register. Registered $31 or return address. This register dedicated for this purpose. On the restoring the return address of a function, So when we execute jump and link, first the return address or the content of the program counter plus 4 should be a store in register is stored in the registered $sign or a return address register. Then the program counter will be launched with it's thought out of the function. And we execute the first instruction of the function. When we reach to the end of the function, we should return back to the color program. We have a specific instruction again, jump register. JR. Jump register, jump to the address that is a store in this parameter. So here we say that jump registered a $sign or a inside the A or return address register. We store the return address. So when we say that jump register $sign or A, it means that return to the next instruction after jump and link. So let's see how we can translate this code into the MIPS assembly language. This is the main function and this is the factorial function. Here we call factorial and pass some parameter like 8 to the function factorial and store the result somewhere. For now we only focus on how we can call this function. In the next part, I will show you how you can pass this parameters and this return value to the color program. But for now, jump and link. Fact, when this line executes, the return address, which is this one, will be a store in register or a return address $sign array. Then we come to this line and run this code. The implementation of the factorial should be written here, and in the fine end of the factorial we should return back to the color program for this purpose. The return or return. In fact, the return instruction in assembly will be jump register $sign or A. By this way, we come back to this line and again we call the same function. But this time the return address is L2. So this L2 address will be a store in $sign array. We come to the fact function, execute this instructions and return back to the next line after jump and link instruction here to the L2 label. Also, as you know, the main function is also a function. Here we can use jump register, but our sign are in the end of the program in order to come back to the operating system. But it's not necessary for now. You know that the functions accept arguments and produce return values. For example, here the 8 is the input argument of the factorial and the return value store in variable t. When we call a function, this value will be passed to the local variable and here, and this code generate the return value, and by return, if we return the result to the color program and this result store inside this variable, for example, T1. And this should be T2. How we can pass parameters to their function in MIPS. As I said, MIPS use the following conventions for function arguments and results. You can pass up to 4 parameters by a register, a $sign, a 0, a 1, a 2 and a 3. These are the argument registers. So before you call a function by using jump and linking instruction, you should put the corresponding argument inside the one of these registers. For example, in the factorial we only have one argument, so we use $0 before I call. Jump and link. Fact, I should put the parameters inside the $0 and the function can return up to 2 values by placing them in registered $V0 and V1 before returning via jump return instruction. So when your function want to return something to the color, this result should be a store in registered $V0. And after we return back to the color program, the color can find the result from this specific register. The conventions are not enforced by the hardware or assembler, but programmers agree to them. So functions written by different people can interface with each other. Okay, let's complete the factorial example. This is a factorial function in C code. We initialize the variable by 1. For example f, then we multiply number between 1 to end with each other one by one, and store the result inside the f variable. And finally, when this is completed, we should return the value inside the variable f to the color. As the factor resolved here in a set of variable f, we use the register value outside 0 and instead of this variable we use $T1. So this loop start from end and every time it's decrement it by 1 unit. Here we say that n should be a store inside the AI in the MIPS assembly. We use a register instead of a variable for counter. In this line, we have the condition of the loop branch if less than or equal the value of the counter, and 1 should be checked if it is less than or equal to. If it is less than or equal to 1, then we go to the return label. So if it is greater than 1, we come to the multiply. And we multiply the value of the it1 with the f and store it inside the f. This is T0, it's corresponding to the f, and T1 is corresponding to the I. Then we decrement 1 unit from the loop counter and jump back to the loop condition here. Again, if the I is less than or equal 1, we should go out from this loop. Otherwise we continue. So when we come to the return, the result will be inside the T1. Sorry. T00 is the F and we should save it inside $V0. And finally, instead of return we have a specific instruction jump register, $or a. So as you can see, this is the way that we return some value to the color program in the main program. Let's see how we can send some argument to this factorial function. As I said, we should save the input argument inside $0. So by load immediate we put value 8 inside $0. Call the factorial function by jump and link. That should be here. Jump and link JL not J. Jump and link fact. And after that the result is inside the $sign with 0. We should save it sample in some place. For example, we save it in $1. It's not a good idea because we use 3-1 inside this program, so it should be saved somewhere else again. Save it in, for example, T3 T4 register. Don't save it inside RT1. And here we are again. You want to call the factory this time by parameter 3. Find the factory 3. So put 3 inside $180. Jump and link. Fact, and the result should be a store in another register. Let me check that it can be used too. Yes, T2 is free. So instead of T1, we should use T384. And finally, these two answers should be up to each other. You can add this one and save it in some place.